Good day, students. For today's discussion, you will learn about illustrating events and union and intersection of events. And our objectives: students should be able to illustrate events, union of events, and intersection of events. First, let us define the following terms. An experiment is any procedure that can be repeated theoretically an infinite number of times and has a well-defined set of possible outcomes. Each possible result of an experiment is referred to as a sample outcome. The set of all possible outcomes is called the sample space and is usually denoted by S. A subset of the sample space S of an experiment is called an event. So here are the examples of sample space. Number 1. Roll a die and observe the number that comes up. The sample space consists of a finite set of outcomes. In particular, S is equal to 1, 2, 3, 4, 5, 6. So as you can see here, that if we are going to roll a die, the possible outcome or the sample space, we can have here 1, 2, 3, 4, 5, and 6. Let us continue our examples. So number 2, toss a coin. In tossing a coin, either a head or letter H or a tail letter T will appear. Thus, sample is equal to H and T. So again, if we are going to toss a coin, the possible outcomes is it is either head or tail. So you can see here that S is equal to H and T. Let's proceed to number 3. Turn on a light bulb and measure its lifespan. Some light bulbs do not even turn on, and so its lifespan is 0 hours. While light bulbs eventually die out, any bulb that lights up can theoretically last any possible real numbers of hours. In this case, the sample space is infinite, consisting of all non-negative real numbers. S is equal to 0 and infinity. Number 4. Flip 2 coins and observe the sequence of heads and tails. Each outcome is an ordered pair of results from each coin. Letting H or head and T or tail denote a head and a tail again respectively. It is easy to see by listing the sample space has exactly 4 outcomes. So if you are going to flip or toss 2 coins, so here are the sample outcomes. We have here head and head, head and tail and head, and tail and tail. Our last example of sample space, colors of a rainbow. So let us list down all the possible outcomes or sample space for the colors of a rainbow. So S is equal to red, orange, indigo, green, blue, and violet. We are done with listing or giving examples of sample space. Now, let us illustrate an event. Again, an event is usually denoted by a capital letter, followed by either a description or a list of all the outcomes which are included. Example number 1. Rolling a die and observing the number that comes up. 2 possible events can be defined as follows. Number 1, the outcome is odd. And next is the outcome is at least 4. This can be viewed as subsets of the sample space, or S, with A. So if we are going to roll a die, what are the possible outcomes? That the outcome is odd numbers. So for letter A, it is 1, 3, and 5. And the answer for the letter B, or the outcome, that if we are going to roll a die, the outcome is at least 4. So B is equal to 4, 5, and 6. Example number 2, performing the sample experiment in example 1, that if we are going to roll a die, consider the following events. Letter C, the outcome is at least 7. And letter D, the outcome is either odd or even. So if we are going to answer letter C, the outcome is at least 7, so C is an empty set, or you can see here the sign of 0 and then a slash. Because if we are going to roll a die, and if we are going to look for the outcome that is at least 7, we all know that if we are going to roll a die, the possible outcome is only 1, 2, 3, 4, 5, and 6. So if we are going to look out for the outcome that is at least 7, so it is an empty set. Again, it is an empty set. You see here the symbol for empty set. And take note that empty set is different from 0. Okay, so letter D, the outcome is either odd or even. So D is equal to 1, 2, 3, 4, 5, and 6. So you can see here that we list down all the possible outcomes when we are rolling a die. So you can see here the number odd and the number even. This means that an event may also contain no elements, or this is an empty set. So you can see here in our answer in letter C. So we are done giving examples for the sample space and illustrating events. So an event can be simple or compound. A simple event is an event with a single or one outcome. Please take note of this. Again, a simple event is an event with a single or one outcome only. So here are our examples. Rolling a die and getting a 2. If you roll a die, the number that would come up could be 1, 2, 3, 4, 5, or 6. When the die is rolled, it is equally likely to land on the one face as on any other. Or simply, if you are going to roll a die, the possible that we can get a number 2 is ones, because in a die, we have here the number 2 written, or the outcome is only ones. Number 2, tossing a coin and landing on a tail. Since the coin can only land on a tail, the number of ways the event can occur is 1. There are 2 possible outcomes: coin landing on a head or a tail in the sample space. So, number 2, if you are going to toss a coin, the possible outcome is either a head or a tail. So, we can only have single outcome for tail. So, this is an example of an event. So we are done giving example with the simple events. Now let us move on to a compound event. And what do we mean in a compound event? So the events that can be combined to form a new event, which is called a compound event. Or a compound event is an event consisting of two or more simple events. Examples: rolling a die and spinning a color wheel. So if we are rolling a die and spinning a color wheel, so there are many possible outcomes. So we can have here one and color yellow, one and color red, one and color green. So you can see here that we have two or more simple events or outcome. So this is an example of compound event. So here is another explanation. If you roll a die and it is equally likely to land on a one number as on any other is an event, and spinning a color wheel that comes up on one color as on any other is also another event. Combining the two events define a compound event. Or, rolling a die is an example of simple event. And spinning a color wheel is an example of a simple event. So if we combine these two simple events, it is called compound event. So let us continue giving examples for compound events. And number 2 is getting an even number from rolling a die and a head in tossing a coin. So you can see here that we have here two simple events. So first is getting an even number from rolling a die, and the second one is a head in tossing a coin. So if we are combined these two simple events, this will lead us to compound event. And if we are going to list down all the possible outcomes in number 2, so we have here two or more possible outcomes. So it can be 2 and a head, 4 and a head, and 6 and a head. So this is called a compound event. Or, since the die can only land on even numbers, the number of outcomes the events can happen is 3, as stated earlier. And landing a head in tossing a coin, or rather tossing a coin, is once. Therefore, the said experiment suggests a compound event. So next, for number 3, getting an odd number when rolling a die. In rolling a die, the sample space is 1, 2, 3, 4, 5, and 6. So, if we are going to roll a die, the sample space that we can have are the numbers 1, 2, 3, 4, 5, and 6. So, if we are going to get an odd number, again, getting an odd number when rolling a die. So we have here the possible outcome of 1, 3, and 5. So we have here the results or the sample space of more than 1. We have 3, 1, 3, and 5. These are the odd numbers or the possible outcome when we are going to roll a die. And if we are going to get or we want to get an odd number, so these are 1, 3, and 5. So this is simply called as the compound event because we have two or more possible outcomes. Let us have a simple activity. So here is our directions. Identify the following activities, whether an experiment or an event. If an event, tell what type of event. It is simple or compound. So we are going to answer if the given activities is experiment or an event. So if our answer is event, you will tell here if the event is simple or compound. So are you ready? Okay, so get a piece of paper and let us answer the following activities. Number 1, tossing a coin. So write your answer and later on we will check your work. Number 2 is rolling a die. Number 3, tossing 2 dice and getting a sum of 5. Number 4, flipping 3 coins and getting 2 heads. Number 5, spinning a spinner numbered 1 to 8 and land on 8. Number 6, drawing a card from a deck of standard card. Number 7, flipping heads on a coin and pulling a queen from a standard deck of cards. Number 8, getting a sum of numbers. Number 9, selecting a month of the year having letter F. Number 10, choosing a vowel from letters A to D. So you can pause this video for a while to answer numbers 1 to 10. And if you are done with your answers, you can continue watching this video. And after that, let us check your answers. So let us check your work. Number 1, tossing a coin is an experiment. Number 2, rolling a die is also an experiment. So check your work. If you got the correct answer, very good. Number 3, tossing 2 dice and getting a sum of 5. So you can see here that we have here an experiment tossing 2 dice, and there is an specific outcome that he wants to getting a sum of 5. So let's say, for example, in number 3, tossing 2 dice is an example of experiment only. But you see here that tossing 2 dice and then added getting a sum of 5, he stated here the possible outcomes that he want to get, which is getting a sum of 5. So this is an example of an event and it is compound. So we can see here the 2 simple events, or if we are going to list down all the possible outcomes, so we have here 1 and 4, 2 and 3. So we are having 2 or more possible outcomes. So this is a compound event. Number 4 is flipping 3 coins and getting 2 heads. So if we are going to flip 3 coins and getting 2 heads, it is an example of event, and this is compound because we can have here tail, head, head, or head, head, tail, or we can have here head, tail, head. So those are the possible outcomes. So this is an event and it is a a compound event. Number 5, spinning a spinner numbered 1 to 8 and land on 8. So this is simply an simple event or event simple. Okay, so you can see here that we have here an experiment and it is stated here the specific answer that he wants to get. So again, in number 5, if it is written only in spinning a spinner, it is only an experiment. But you can see here that we have here added numbered 1 to 8 and land on 8. So this is again event or simple event. Number 6, drawing a card from a deck of standard card. So, or picking a card from a standard deck of card. So this is an experiment. Number 7, flipping heads on a coin and pulling a queen from a standard deck of cards. So if we are going to flipping heads on a coin, so we have here a possible outcome of course each, and pulling a queen from a deck of cards. So we have here an possible outcomes of head and then queen of hearts, or we can have here head and then queen of spade, head or queen of flower, and then head and queen of diamond. So we have here 2 or more possible outcomes. So this is event and it is a compound event. Number 8, getting a sum of numbers. So you have here an experiment because it is not indicated here the specific outcome that we want to examine. So it is an experiment. Number 9, selecting a month of the year having letter F. So it is stated here the specific month that he wanted to examine or to see the possible outcome. It is having letter F. So we have here event simple because in selecting a month of the year having letter F, it is only February. So we have here possible 1 outcome. So this is simple event. And number 10, what is your answer in number 10? Choosing a vowel from letters A to D. Okay, very good. The answer here is event, and this is a simple event because we have here possible outcome A to D, and the vowel from choosing letters from A to D, we have here a possible outcome of 1 only. So it is letter A. The letter A is the only vowel from the letters A to D. So this is event simple. So I want you to count all your correct answers. And if you got all of this correct, you are very good. So let us continue with our discussions. And this time, we are discussing about the union of 2 events is all outcomes in either or both events. So the union of 2 events, A and B, denoted by A union B, or you can see here the symbol for union, which is letter U. The event A union B, again it is read as A union B, comprises the set of outcomes of A and or B. For example, if A is equal to 2, 4, and 6, and B is equal to 1, 2, 3, then A union B is equal to 1, 2, 3, 4, and 6. So in union, you can see here again 2, 4, 6, and in letter B 1, 2, 3, simply get all the possible outcome. So you see here number 1, number 2, you can see here the number 2. So you can see here number 2 is written or repeated twice, but you only have to write it once. Next is number 3, number 4, and number 6. So A union B is equal to 1, 2, 3, 4, and 6. You list all the possible outcomes. Okay, so using the Venn diagram to depict the union of the events A and B in a dye experiment, we have, so if you see this figure, you can see here two circles overlapping. This is for experiment A, and this is for experiment B. So, and then right here U for universal. So you can see here the graph or the diagram. It is called Venn diagram of union. See here an overlapping. So this is the Venn diagram for a union. So let us create a Venn diagram from our example. A is equal to 2, 4, and 6, and B is equal to 1, 2, and 3. So if we are going to create a Venn diagram, so it looks like this. So you can see here first is to draw a box, and inside the box we have here two circles. For letter A, you can see here letter A, capital letter A, and capital letter B for a green circle. And you see here the two overlapping circles. And do not include to write this symbol for universal. And inside the circle A, you see here the color blue. So we have here 4, and the next one is 6. And for this overlapping circle, we just have to write number 2, since we have the same possible outcome, number 2 in A and in B. So we have again possible outcome. They are the same. We have number 2 in A and we have number 2 in letter B. So we need to put it in this overlapping circle from A and from B. And for letter B, this green circle, so we have here 1 and 3. 1 and 3. So you do not have to write the number 2 since it is their possible outcome that we have for letter B. So again, you see here that for letter A we have 2, same with letter B we have 2, so we need to write it in the middle part of the circle, or you see here in the overlapping part of the circle. So the universal set U is the sample space S, the shaded region, or you can see here the color gray. So this is the shaded region, the color gray. Inside the circle is the union of A and B. Okay, we are done with our Venn diagram. So you can see here our Venn diagram in finding A union B. And if we are going to list down our answer, A union B is equal to 1, 2, 3, 4, and 6. You can see here that the number 2 is the possible outcome for A, and for B, we just have to write it once. Or simply look at our circle and then write all the possible outcomes. So 1, 2, 3, 4, and 6. Okay, I hope you get our answers. So let us find our next example. So we have here the given again S is equal to 5, 10, 15, 20, 25, 30 with the sample space of an experiment. T is equal to 5 and V is equal to 5, 20, 30 and W is equal to 10, 15, 25. Be the events of the experiment. And we are going to find T union V. So again, in union, and if you are going to use the Venn diagram, so this is first, we have to write the what are the possible outcomes for letter T. So this is 5 and 10. And for letter B, we have 5, 20, and 30. And as you notice, 5, they have the same possible outcome for 5. So I underline it. Put an underline. And this is the Venn diagram for union. So let us continue to draw or create a Venn diagram. So let us create a Venn diagram for our example number 1. T union B, we have here in T 5 and 10, and in V we have here 5, 20, and 30. And as you can see here, we have same possible outcome 5 for T and for V. So we have here a Venn diagram for union. So it looks like this. And then we have to write T for our first event for the letter blue circle and V for our green circle. So next is write all the possible outcome for dt. So I have here 10, and then you see here that I write 5 in this middle of these two circles, or the overlapping part of the circle, since they have the same possible outcome for 5. So for V, we have here 20 and then 30. So this illustrates the Venn diagram for T union V. And if we are going to write all the answer, or T union B is equal to 5, 10, 20, and 30. So you see here that we only write 5 once, since it is the repeated possible outcome for T and B. Or just simply look at our Venn diagram here. 5, 10, 20, and 30. So we are done with the union of events, and then we answer it using Venn diagram. So next is the intersection of two events. So what is the intersection of two events? It is the only outcomes common in both. Again, the intersection of two events is only those outcomes common in both. So in the intersection of two events A and B is denoted by A. So this is the symbol for intersection B. The event A intersection B is read as A intersection B, comprises the set of outcomes common to A and B. For example, if A is equal to 2, 4, 6, and B is equal to 1, 2, 3, the end intersection B is 2. So because we have common outcome, number 2 in A, and also of course number 2 in letter B. Using the Venn diagram to devisit the intersection of the events A and B in a die experiment, we have, so as you can see here, this is the Venn diagram for intersection. Same with the union, we have here two overlapping circles, but the only shaded part here is here. And of course, do not write the universal. So let us answer. Again, we need to find for the A intersection B. Of course, this is the Venn diagram for intersection. And then do not forget to write U. And then this is intersection, so we have to shade this overlapping part or the middle part here of the circle. Okay, and then of course you have to name the circle A for our example, and then B, so you can see here in the pink circle. And let us list down the possible outcomes for A and write it inside the circle. So we have 4 and then 6. And we need to put the number 2 in the middle part or in the overlapping lap of these two circles. And then do not forget to shade it. You see here the shaded part, color yellow, to indicate that this is intersection, A intersection B. And for letter B, we have 1. And of course, we do not write 2 because it is the intersection part. And 3. So this is for B. The shaded region is the intersection of A and B. You see here again the color yellow. So again, if we are going to create a Venn diagram for intersection, do not forget to shade this part. And if we are going to list the answers, so A intersection B is equal to 2. Okay, you can see here the shaded part here is number 2 only, and it is written as, put here a braces. Okay, this is the brace symbol. Again, A intersection B is equal to 2. Let us have another example. So again, this is our given, and our task is to find T intersection V. So we have here T. So the given here for T is 5 and 10. And then for letter B is 5, 20, and 30. So again, we need to find for the T intersection V. The first thing that you do is to list down the given. And then we are asked to create a Venn diagram. So this is the Venn diagram for intersection looks like, and do not forget to write the universal symbol. So this time I want you to create a Venn diagram for number 1. And if you are done answering, you may continue watching this video. So let us find the intersection B. As you can see here, our given and our Venn diagram for intersection. And then you can see here that the only shaded region here is the overlapping part of the circle, or the middle part here. The shaded region is the color yellow. I color it as yellow. And then do not forget to write T. And then the given V. The circle pink here for V. And then write 10 under the circle of T, the color blue. And then we have here 5. I write it in the shaded part of our circle because, so you can see here, we have the same outcome, number 5 for event T and V. And then for letter B, we are done with T. So next is V, 25. So do not write 5 because we already write it. And then we have 30. So this is the Venn diagram for T intersection V. And if we are going to list the answer, so T intersection V is equal to 5. Or just simply look at the shaded region here. So the answer is T intersection V is equal to 5. Let us have example number 2, and in number 2, we are going to find for the T intersection W. Again, here is our given. So we need to find for the intersection of T and W. So first thing that you have to do is to list down the given. So for T, we have 5 and 10, and for W, we have 10, 15, and 25. So this time, I want you to answer T intersection W using Venn diagram. So you may pause this video, and if you are done answering, you may continue to see if your answer is correct. So let us see if your work is correct. So again, here is our given, and we are asked to find for the T intersection W. Here is our Venn diagram for the intersection, and then of course we write T and then W. Do not forget to write the given. And okay, we can write here at the middle part, the intersection is 10. So you can see here, we have same possible outcome or results for T and W. Okay, and then for T, we have here 5. Then for W, possible outcomes, 10 of course, and then 15. Next is 25. So this is the Venn diagram for T intersection W. You got it correct? Awesome! So the answer, T intersection W is equal to 10. To end our discussion, let me sum up what is the difference between union and intersection of events using Venn diagram. So first, we have here the union of event, and this is the Venn diagram for union of event. You see here that inside the circle, we shaded all the regions of it. So union of event is the all outcomes of both event, while the intersection of event, so you see here that the Venn diagram for this, we have to only shade the region of the overlapping part or the middle part here of the circle. You see here the color yellow to indicate the intersection of event, and it is the common outcome for the two events. So I hope that you learned about the union and intersection of event.